In this video, I'm going to talk about the unit circle. The unit circle is a circle with radius 1. That's why it's called the unit circle. And it's really simple, so it's a great way to learn and talk about lengths and angles for trig. It's also something that you have to memorize because you will need to know the exact values for specific angles, and those angles that you need to know are the ones on the unit circle. So the unit circle is a circle of radius 1, centered at the origin, and given by the equation x squared plus y squared equals 1. It is the basis for trigonometry. So it is the basis for trigonometry. All right, I'm going to label the unit circle. This is our unit circle here that I've created. This point here in the center is 0, 0. And I know this circle has a radius of 1, so I'm going to label this point here is 1, 0. This point here is going to be 0, 1. This point here is negative 1, 0. And this point here would be 0, negative 1. Okay. Then I'm going to just focus on the first quadrant here. So this here is a terminal side. I know that my angles, I talk about angles on the coordinate plane coming from the positive x-axis going to the terminal side. So this would be my first terminal side that's drawn in the unit circle. The angle here from the positive x-axis to that terminal side is going to be 30 degrees. If I created a right triangle that fit perfectly into this circle here, that the hypotenuse goes from the center to this point on the end of the circle. I know the hypotenuse of that right triangle that I create is going to be 1. And we talked about this last time I saw you. But this is a special right triangle. This is a 30-degree angle. This is a 90-degree angle. That makes 120 degrees, so there's 60 degrees left to make an entire triangle. And I know this is now I know for sure this is a special right triangle because it's 30, 60, 90. If the hypotenuse is 1, then I know the small side we talked about is 1/2, and the large side is the square root of 3 over 2. That would make this point here, I know my horizontal distance, my horizontal distance is going to be what x is here. And that horizontal distance is the square root of 3 over 2. I know my vertical distance, so my y value at that point on the unit circle is going to be 1/2. So I'm going to put that in. All right, next I'm going to talk about the next terminal side in quadrant 1. So this terminal side here, the angle here is 45 degrees, and that's just given. So you need to know the 30-degree angle, the 45-degree angle, and then there's also a 60-degree angle that will be drawn in the unit circle as well. That will be the next terminal side that we look at. So this is a 45-degree angle. You can see it cuts the quadrant in half, and the quadrant is 90 degrees. If I create a right triangle like I did before with the other terminal side, I know that this is an isosceles triangle because I have 45 degrees here, 90 degrees here, and I need another 45 degrees to finish this triangle. And so this is an isosceles triangle, which means that the side lengths here and here are, that's x and this is y. X and y should be the same when I come up with a coordinate for this point here. I know that this has a radius, the unit circle has a radius of 1, so the hypotenuse of this right triangle that I create is 1. And then I know based on what we did yesterday, if you look at your notes from 4.3, this would be the square root of 2 over 2, and this would be the square root of 2 over 2. Those side lengths. So I know that this coordinate right here, the horizontal length, so the x value at that point is going to be the square root of 2 over 2. And the y value is the height of this triangle, which is also the square root of 2 over 2. All right, so that's my second point in the unit circle for the 45-degree angle form. So let me leave these angle, so this was 30 degrees, and this is 45 degrees. And then the last terminal side that I have drawn in the first quadrant of the unit circle is here. And oops, I'm going to draw a right triangle with it. And I'm going to tell you that this angle, like I think I already said before, is going to be 60 degrees. If this is 60 degrees and this is 90 degrees, then to complete my circle, this would have to be 30 degrees. So this is also the same special triangle we looked at before with the 30-degree angle. It's a 30, 60, 90 degree triangle. This is my hypotenuse. The hypotenuse is still 1. The small side is still going to be 1/2, but it's the x value in this case. And the height of that right triangle is going to be the square root of 3 over 2. So I'm going to put my coordinates here. I know the horizontal length is 1/2, and the vertical length is the square root of 3 over 2. And so that would be my point on the unit circle if that angle was 60 degrees. There will be 3 terminal sides in each quadrant, and it will always be 30 degrees from the x-axis, 45 degrees, and 60 degrees from the x-axis. I also know that this, the point 0, 1 is associated with 90 degrees. We talked about what each quadrant was worth. -1, 0 is going to be 180 degrees, and 0, -1 will be 270 degrees. So 270 degrees. This is 1, 0 is 0 degrees, or we can also say is 360 degrees as well. Okay, now that I've done that, I'm labeled the first quadrant. I should be able to very easily find everything in the other quadrants. This angle here, or this terminal side here, makes an angle of 30 degrees with the positive x-axis, or with the x-axis. So does this terminal side here. This angle is also 30 degrees. And if I were to create the right triangle over here that I did before, this is 30 degrees, 60 degrees, 90 degrees, then I would see the opposite of what I saw on this side, or not the complete opposite, but this side is 1/2, this side is the square root of 3 over 2. And so, but I know I'm going in the negative direction for the square root of 3 over 2. So the coordinate here would be a negative square root of 3 over 2, 1/2. How does that compare to this point here? Well, I just have the x value is the opposite of what it was in this quadrant, which makes sense because I should have a negative x value and a positive y value in the second quadrant. this is going to be the case for all of the terminal sides in the second quadrant. They are going to have the same absolute value for x and y as the first quadrant. So these two terminal sides line up together. These two terminal sides line up together. And these two line up together. Oops. That would make this point, all I have to do is take this point here and just make the x value negative. So I have negative square root of 2 over 2, comma square root of 2 over 2. For this point here, all I have to do is take this point here and just make the x value negative. So I have negative 1/2, comma square root of 3 over 2. This is the case in all the quadrants. So going to quadrant 3, I know this angle here is going to form a 30-degree angle, because I'm only talking about the 30, 45, and 60-degree angles from the x-axis. So this is 30 degrees from the x-axis. This is 45 degrees from the x-axis, and this is 60 degrees from the x-axis. So this the first one corresponds to 30 degrees. The second one corresponds to 45 degrees, and the last one corresponds to the 60 degrees. So these points are going to correspond to what I have in the first quadrant. So the point here would be, well, in the third quadrant, I should have a negative x value and a negative y. So it would be negative square root of 3 over 2, negative 1/2. This here would be, I'm looking at my blue point, it was square root of 2 over 2, square root of 2 over 2, so now it's negative square root of 2 over 2, and negative square root of 2 over 2. Then the green would be 1/2, comma square root of 3 over 2, but it would be negative 1/2, negative square root of 3 over 2. And then I'll finish this over here. So I'm looking for, in the fourth quadrant, this first terminal side here is going to line up with the red terminal side that I have in each other quadrant. So its first point is going to be square root of 3. Its first coordinate's going to be square root of 3 over 2. Second one's going to be 1/2. But in the fourth quadrant, I should have a positive x value and a negative y value. So this would be negative 1/2. Here I would have square root of 2 over 2 and negative square root of 2 over 2. And here I would have 1/2, comma, negative square root of 3 over 2. So those are all the points that I have on the unit circle. Now I want to talk about the angles. So the angles that I have are in the first quadrant. I already drew them. I know that in order to find what this angle would be, but in the positive direction, I would subtract 30 degrees from 180 because this is 30 degrees. So this would be 150 degrees. And then for this one here, this angle is 45 degrees, so I would subtract 180 minus 45 to get 135 for the degrees that I see there. And then this, going from here to here, would be, this would be 60 degrees. So I know that the angle here would be 120 degrees. Okay. Then in the fourth quadrant, this is 30 degrees. So I am adding 180 plus the 30 to get, this would be 210 degrees. This is 45 degrees, this angle from the x-axis to that terminal side. So I know I would take 180 and add 45 to it. So I'd get 225 degrees. Then I know this angle from the x-axis to here is oh my God, I'm sorry. It's 60 degrees. So if I added that to 180, it would be 240 degrees. And then going from here, this angle here is 30 degrees. So what I would want to do to find, so I want to find the positive angle going to it from the positive x-axis counterclockwise. If this is 30 degrees, I'm going to subtract that from 360 to get that this is 330 degrees. I'm going to subtract 45 from 360 to get what this would be in, this would be, and that would be, 315 degrees. And then this would be from the x-axis to here would be 60 degrees. So going positive direction to get there, that would be 360 minus 60, which is 300 degrees. Okay. And then we also want to put in radians. So we also want to memorize the radians for all of these angles. Well, to go from 30 degrees to radians, I would do 30 times pi over 180. I would see that 30 and 180 had something in common, and what they have in common is 30. And then if I do 180 divided by 30, it's going to be 6, and 30 divided by 30 is 1. So this would also be pi over 6 in radians. I know that to go from 45 degrees to radians, I would multiply 45 times pi over 180. 45 and 180 do have something in common. They have 45 in common. So 180 divided by 45 is 4, and 45 divided by 180 divided by 45 is 4, and 45 divided by 45 is 1. So this is also pi over 4. The other thing in this quadrant we have is 60 degrees. 60 times pi over 180. 60 goes into 180 3 times. So I'm going to have pi over 3 is the radian measure of 60 degrees. It's the same as 60 degrees. To find the other ones, I'm just going to use the fact that I know that all of these angles that I've labeled are 30, 45, and 60 degrees from the x-axis, or pi over 6, pi over 4, pi over 3, away from the x-axis. So I'm going to label the major point, so 1, 0, 0, 1, -1, 0, and 0, -1. 1, 0 I know is either 0 radians or 2 pi radians. 90 degrees we talked about is pi over 2 radians. 180 degrees we talked about is pi radians. And 270 we talked about being 3 pi over 2 radians. So I'm going to use those important pieces to find, or really I'm just going to use this and this to find the other things in radians. In order to find this angle going from the positive x-axis to this terminal side, I'm just going to focus in on the fact that this is pi over 6. So what I could do to find what this angle is here is I could do 180 degrees minus 30, or pi minus pi over 6. So I could do pi minus pi over 6. I know they have to have the same denominator for me to be able to subtract them. So this is actually 6 pi over 6 minus pi over 6. So this would be 5 pi over 6. For 135 degrees, that's 135 degrees going like this. I know this angle here is 45 degrees. So it's also, in radians, pi over 4. I'm going to do the same thing I just did, and I'm going to do pi minus pi over 4 to get what this angle will be like this. And I need the same denominator, so I'm going to do 4 pi over 4 minus pi over 4, which gives me 3 pi over 4. And so this would be 3 pi over 4. And then I also need this angle here, I know is going to be pi over 3. So I'm going to do 3 pi over 3, that's pi, equivalent of pi, minus pi over 3, which gives me this is 2 pi over 3. So those are my radians for there. Same thing in the third quadrant. This angle from the x-axis is pi over 6. I know that means I'm going 180 degrees or pi and adding pi over 6 or 30 degrees. And so I'm going to, in order to be able to find it, I'm going to do pi plus pi over 6, which is the same as 6 pi over 6 plus pi over 6, which is 7 pi over 6. And I'm going to do that also for this angle here. I know is pi over 4, so I'm doing 4 pi over 4, which is pi, plus pi over 4, which gives me 5 pi over 4. And then lastly, I know this angle here is pi over 3, so I'm going to add pi plus pi over 3, pi plus pi over 3. This is 3 pi over 3 plus pi over 3, which is 4 pi over 3. And then I'm going to do the same thing in the fourth quadrant. So I know this angle here that I drew was pi over 6. And so what I'm going to do to find full circle, is what I did with the angle. So this is pi over 6. I want to find the rest of that circle. So I want to take it away from 360 to find what the angle would be in the positive direction from the positive x-axis. So this would be 2 pi minus pi, because that's a full circle, 2 pi minus pi over 6. And then I changed this to 12 pi over 6 minus pi over 6, which gives me 11 pi over 6. Then this angle I knew that I drew is pi over 4. I want to go full circle minus pi over 4. And so I'm going to do 2 pi minus pi over 4. This I'm going to change to 8 pi over 4 minus pi over 4. 8 pi over 4 is the same as 2 pi. And I'm going to get 7 pi over 4. And then this angle here I know is pi over 3. So I want to go full circle except minus pi over 3. So I'm going to do 2 pi minus pi over 3. And I'm going to rewrite 2 pi as 6 pi over 3. And then I'm going to get this as 5 pi over 3. Okay, that's the unit circle and all the things that you need to know on the unit circle. The radians, the degrees, and the coordinates. A special thing about the coordinates is that all the x values are equal to cosine of theta, because it's going to be the horizontal, I know it's going to be for cosine adjacent over hypotenuse, but the hypotenuse is 1. So I'm just going to have the x value over 1 or just x when I do cosine of theta. And when I do sine of theta, I know that's opposite over hypotenuse, so it's going to be the y value over 1, but that's just going to be the y value because I don't need to write the 1. So these two things are also important to know, that x is always equal to cosine of theta. Like, for example, if I did cosine of 30 degrees, I would get the square root of 3 over 2. And if I did sine of 30 degrees, I would get 1/2 because it's always going to give me the y value. So that's why these coordinates are important. The x values in the coordinates are always equal to cosine of theta, and the y values in the coordinates are always equal to sine of theta. Okay, next, trig functions. There are the ones that we talked about were cosine, sine, and tangent, the first 3. And then we also talked about cosecant, secant, and cotangent. And I want to talk about them in terms of what they're going to be as far as the unit circle goes. So cosine of theta is always going to be equal to x. Sine of theta is always going to be equal to y. We just talked about that. So tangent of theta is going to be sine over cosine. So I know it's going to be y over x. And then I also know that x cannot be equal to 0 for a tangent to exist. Cosecant of theta, actually let's do secant because it's the reciprocal. So secant of theta would be 1 over x, where x cannot be equal to 0. Cosecant of theta is 1 over y, so that the reciprocal of this, where y cannot be equal to 0. And then cotangent of theta is equal to x over y, so the reciprocal of this, and y cannot be equal to 0. And so those are the 6 things that you need to know as far as the unit circle goes. So you should be able to find cosine, sine, tangent, secant, cosecant, or cotangent of any angle that's on the unit circle, whether it's given to you in degrees or radians. I want to do an example of evaluating the 6 trig functions for theta equals pi over 3. So I'm going to do sine of pi over 3, which I know is the y value in the unit circle. So I'm going to look at for pi over 3, and pi over 3, the y value is, it's the square root of 3 over 2. So it's going to be equal to the square root of 3 over 2. For cosine of pi over 3, I know that's the x value for pi over 3 on the unit circle. So pi over 3, it's 1/2. So I'm going to put that here, 1/2. And then for tangent of pi over 3, I can just use what I have for x and y already. I'm doing y over x for that, and that's going to be, in this case, the square root of 3 over 2 all over 1/2, which gives me the square root of 3. Then if I do the reciprocals, so if I do secant of, cosecant is the opposite. So cosecant of theta would be equal to 1 over y. So I would just flip this. So I would have 2 over the square root of 3, and then I can't leave a square root in the denominator, so I multiply by the square root of 3 over 3. The square root of 3 over the square root of 3, a giant 1 that doesn't change the value of that fraction, and I'll have 2 square root of 3 over 3 as my answer. For secant of theta, which is the reciprocal of cosine, I'm going to just flip 1/2, so I'll have just 2, because it's going to be 1 over x, or just the reciprocal of whatever I got for cosine, and so that's going to be 2 over 1, or just 2. And then for cotangent, I'm just doing the opposite of the square root of 3, so I'm going to have 1 over the square root of 3, which I have to rationalize by multiplying by the square root of 3 over the square root of 3. And so I get the square root of 3 over 3. Oops. And then evaluate the 6 trig functions for 3 pi over 4. So I'm going to look on my unit circle, and I'm going to look at 3 pi over 4. Actually, why don't you pause the video and try this on your own? All right, welcome back. Please don't just copy these and try it on your own. Okay, sine of 3 pi over 4, you should have got square root of 2 over 2. For cosine of 3 pi over 4, you should have got negative square root of 2 over 2. For tangent of 3 pi over 4, you should have got negative 1. And then for cosecant of 3 pi over 4, you should have got the square root of 2. For secant of 3 pi over 4, you should have got negative square root of 2 over 2. Oh my god, negative square root of 2, just that. I don't know what I'm not feeling very well, guys. Cotangent of 3 pi over 4 is equal to negative 1. And that's what you should have got for the 6 trig functions for 3 pi over 4. 3 pi over 4, I look here, I know 3 pi over 4 is this point here. This is where I took my x and y value, or my cosine and sine values from. All right, the last thing I'm going to talk about is even and odd trig functions. We've talked about even and odd functions before. It's the same thing here. If I have an even function, that means that if I plug in negative x into the function, I'm still going to get out f of x, the original thing that I started with. So if I plug in negative x, it's still going to be the same as plugging in positive x. If I plug in negative x into an odd function, it's actually going to give me the opposite y value, or the opposite of the original function. So even functions are going to give me the original if I plug in negative x, and odd functions are going to give me out the negative version of the original. In this case, we're talking about theta, so if I plug in a negative theta, it's going to give me the same thing as plugging in that same positive theta, and if I plug in negative theta for the odd function, it's just going to give me this, the opposite of if I plugged in the positive version of that theta. So even trig functions are cosine and its reciprocal secant, and the odd trig functions are sine, its reciprocal, so cosecant, and tangent, and its reciprocal cotangent. So even trig functions are just cosine and its reciprocal, and everything else is an odd trig function. Let me show you what this means. So for example, if I was talking about pi over 4, so this angle pi over 4 is, and this angle negative pi over 4, those are, like, if I plugged in this, it would be the negative version of this. Pi over 4, I know if I am looking at cosine, so if I did cosine of pi over 4, I know from the unit circle it is square root of 2 over 2. So it's the square root of 2 over 2. And then for cosine of negative pi over 4, it's going to be, let's look, negative pi over 4 is 7 pi over 4, or I'm looking for my cosine value, which is square root of 2 over 2. And so it's going to be the same thing. Like, this is the same as this if I plug in the positive version or the negative version. So then that proves that cosine is even. And then if I tried sine of pi over 4 and sine of negative pi over 4, and so what I got for that, sine of pi over 4 is, if we look here, it is square root of 2 over 2, because it's the y value for sine that I'm pulling. And then for negative pi over 4, that's going to be 7 pi over 4 equivalent. And then I know that that is negative square root of 2 over 2. So negative square root of 2 over 2. And so I can see that these are opposites of each other when I plug in the negative versions of each other. So that proves that this is odd. So sine, tangent, if I did it with tangent, I would see the same thing. That I would get the opposite y value if I plugged in the negative version of the angle. Okay, let's do examples. So if I have tangent of x is equal to 2/3, I want to find tangent of negative x. Since I know that tangent is odd, I know that if I plug in negative x, it's going to give me the negative version of the original. And so I would have negative tangent of x, which is tangent of x is 2 over 3. So I'm just going to replace tangent of x with 2 over 3. And so my final answer is negative 2/3. For example 4, if I did sine of negative x, it is 3 over 5. So if I wanted to find what cosecant would be, the first thing that I would need is cosecant of x would be, the first thing I need is what is sine of x, the reciprocal of that. So this would lead to that sine of x, or let me see. This would tell me that sine of x would be equal to the opposite of this. So it would actually be -3/5. And then if I wanted to find a cosecant from there of x, positive x, it would be -5/3, just the reciprocal of this. And so it would be this, because sine is an odd function, so it changes, it is the opposite for the negative version of the angle and the positive version of the angle. So if the negative version was positive, then the positive version is negative. All right, and then if cosine of x is equal to 4/7, I want to find cosine of negative x. Well, this is an even function, so it stays the same. So it's just 4/7. And then if I knew that the negative version, so for a negative angle, or the negative x, oh my god, cosine of negative x is equal to 4/7. I'll just read the paper. I want to find secant. Well, first I'm going to find cosine of positive x, because this is positive in here, and that will give me 4/7. And then I find the reciprocal of that, which is going to be 7/4. So the answer is 7/4.